good friend from South Africa. Greetings to you all. So, okay. So just to take a few steps back onto the project this is on. So we have an Institute of Eminence project all across the IITs in India, and your talk, Thomas, is a part of this project. It's a very large project across several IITs in India, and the particular project in IIT Madras has, I think, more than 30 or 40 sub projects. And one of the areas which our group is focusing on is this whole concept of the circular economy and the automation and recycling in it. So when we look at it from the perspective of both from recycling from a materials perspective, as well as how do we automate several aspects of the process and then bring in low carbon, lean kind of processes in the way we go. India definitely has a lot of construction to be done, unlike in the West, where it is probably more rehab. And if we catch up with the infrastructure, the way the West has it, it is in the way the West is, it's going to be, I think the Earth's going to be a much, not a good place to live in, because the amount of emissions, etc., is going to be very high. So the overarching goals of this project are to look at this from a lean, green way. And I think your lecture, we had a series of lectures on the material side, and the lecture with Professor Bock is now the first lecture on the robotics side. I know that Varun is going to give a detailed introduction to Professor Thomas Bock, but let me do my bit by saying I have known Professor Thomas Bock for probably more than 20 years now. We have been part of the IR community. Professor Bock has been its president for several years. I think under his leadership, it has grown. I have, taken over a few years after him as president of IARC, and we have done a lot with IARC, for IARC, and even the collaborations we have had when I visited his lab, and we are now hoping that Professor Bock will get an opportunity to visit IIT Madras and assist and see the work we are doing here. But to keep it brief, I think if we talk about robotics and construction, I think the first name that comes to anyone's mind is Professor Thomas Bock, and you will get to know why soon. But Thomas, we are very happy that you could make the time to present to us, and we look forward to your presentation.
Mm-hmm.
Varun?
Hello, sir. Yeah, thank you. Now I will first start by introducing the IARC chapter. So I will just share my screen. Okay, so hopefully my screen is visible now. So hello, Chief Guest Professor Thomas Bock and other faculties and those who have joined. Greetings from the IARC IITM student chapter. We started this chapter in 2019 with a small group of students at IIT Madras. And after that, we have set our goals to bring the industry and academia closer and do more on ARC activities, automation and robotics in construction activities. And so we, as all may be knowing, ISARC, International Association for Automation and Robotics in Construction, is a premier global organization which represents a field of construction, including building and engineering. So we are now affiliated to this as our parent body, and it runs ISARC in like every year. So last 2 years were in Banff, Canada and Japan. And after the ISARC at Banff, Canada, we started the student chapter. So our objective is to encourage the execution of fundamental ARC activities and to bring closer the industry and academia. So what our objectives are generally to conduct workshops, have an active membership, active discussions, publish annual newsletters, have monthly activities under the chapter. So we have some of the what work we did in the previous years, like the last 2 years. We publish it as a annual newsletters. So this was the inauguration session where our mentors, Professor Koshi, Professor Benny, Professor Ashwin, have guided us onto what to expect from this chapter and how can we take this chapter as forward. And we had several workshops like the laser scanning workshop. We also toured to Autodesk University, even various events. We had 3D printing workshops last year. We invited speakers from international areas like Oregon State University. Professor Joseph was here, and Professor Pang Jo-chun from University Tokyo was here. So we are active chapter for now, and we have the mentors. This is our team for the session 1920. And we also have a LinkedIn page where all our posts and medias we keep on posting. Recently, the meeting was of like the IARC students chapter formulated a group, and we decided that these all chapters will be grouped together and will be hosted on the IARC web page. So right now you can find all the IARC chapters from various institutes club to that. And yeah, so this is the link to our LinkedIn web page, and this is our email ID if you want to contact us. So this was just a general introduction. We also had yeah. So now I will like to introduce our main speaker for today, which is Professor Thomas Bock. So Professor Thomas Bock is the chair for building realization and robotics at Technical University of Munich, Germany. After his architectural studies at the University of Stuttgart and the IIT in Chicago, he was awarded his doctor's degree at the University of Tokyo. He was the president of International Association for Automation and Robotics in Construction, IARC, during 2005 to 2007. He won numerous international awards, including Tucker Huntsma Award from the International Association for Automation and Robotics in Construction in 2008, 2 gold medals from Russian Academy of Sciences, Section Construction Sciences Foreign Ministry Award for Outstanding Advancement of Cooperation between Science and Industry between Japan and Germany. He was also awarded 2 best papers at ISAR. So this was the brief introduction to Professor Thomas. I now invite Professor Thomas to start the webinar. Thank you.
Okay, thank you, Kumar, for introducing. And okay. So, okay, thank you for inviting me. And I just want to tell you that I'm not showing the existing recycling technologies like a crushers and so on, because it's already available on the market. I'm going to show you a little bit different things, my philosophy for which could be a future closed loop recycling or life cycling by using automation and robotics. And I give you first some overview, which is maybe general known. We can jump over it very quickly because there is not so much time. This is already known, common knowledge from the United Nations. And all the talks about sustainability, the economic, environmental, and social conditions, and to improve also the environment in construction, the dull, dirty, and dangerous jobs, and so on. And of course, the construction waste, which is a huge problem. Most waste by quantity is produced by construction. So here we have to tackle in a different way. And as you heard from my background, I besides since I'm from Germany, besides spending time in Europe, also in the United States, I also spent 5 years in Japan. And I found out that the Japanese culture is kind of interesting because it's actually a country which has no natural resources. So what they did since centuries or thousands of years is that the buildings actually they never destroyed. They disassembled and reassembled them, and So I found this kind of interesting, and you still see this heritage in the present modern factories. I did internships in Toyota Motor Corporation and then moved to Toyota Home. Then I worked with the construction industry and on automation and robotics in construction. So I always found this kind of culture where they kind of reuse and don't create so much waste as we do in Western countries, in Europe or in United States. So I will relate to it on and off. And what are other industries doing? Actually, I get a lot of input from other industries. This was the reason that I built my first house myself as a student when I was 22 years old, and it was very difficult. So since I was a student in Stuttgart, where cars are produced by Daimler-Benz and Porsche, I did an internship at the Daimler-Benz factory, and I happened to see the first robot. And I found out that they are more advanced than construction. So I was looking into this industry as well. Also, when I was Fulbright Scholar in Chicago, I visited Detroit. And then, of course, I found out lots of these projects about the advanced technologies in other industries. And so what we are trying to do is to bring this automation and robotics and industrialization on a broader sense into the construction industry. In fact, we did the first robotic European construction project in the 1990s. It was called Rocco. We also, and this were with the leaders. Actually, there was no budget yet for construction. So I got the financing from the manufacturing sector of the European Commission. And later the construction industry got their own budget. So later we joined other projects like Manubuild, which was headed by British Steel and now Tatra and so on. So many prefabrication, industrialization projects. Maybe for you interesting now is a Zero Plus project. It's near zero emission projects. I will not show much, but you can see it on my homepage, and later during the COE, we can talk more in detail about it. And also projects like using on-site robotics, because most of the stock is already there. And as Professor Varghese mentioned, we have to renovate a lot in Europe. We have this robotic renovation because renovation costs more because more labor intensive. So we have actually 3 projects in this robotic renovation called Bertim, Hefestov, and Ensnare. I show a little bit of it, and also a little bit on the background, as I mentioned, in Japan, where you don't throw things away so much since hundreds of years. I did my first project in the Ministry of Construction at the Research Institute during my PhD. I'm going to show a little bit of it. And then I explained the projects we are doing also for the demographic change in the society. India is maybe not so much hit by this, but European, Japanese societies are aging very quickly. And I'm not sure familiar with the demographic change in India, but we do a little bit here as well. And also here, the interior, which is built in such a way that it can be rearranged, disassembled. So anyhow, the idea is that we have this kind of a triangle between the society, the economics, and the environmental. Actually, in the Greek sense, ecology and economy is basically almost the same. It's the management of the household inside the house and the periphery of the house, which is the Greek meaning of the word. And what I'm trying to do is to bring in the sort of robotic reconstruction, and I try to link it up to the prefabrication, modular prefabrication. So I'm not so much talking about monolithic construction. So this is maybe the basic difference. And another difference is maybe that I stress more about the process rather than the product. It's now in fashion to talk about BIM, but BIM is a product modeling, but I think in construction we need more process modeling. So this is maybe also a little bit different of my approach. So anyhow, what I'm trying to do is to create some robotic repair management scenario. And where we have it's all about, as you can see already, it's about the process. It's the way, it's more about the know-how or the way how we do things rather than talking about the object, which is the basis for also the object-oriented programming. So anyhow, it's more about the know-how and how you do something, how you achieve something, and how you can achieve this kind of life cycling in order to be more sustainable in the future and to reduce the waste in the construction industry. So here, some overview from prefabrication. The tools in the factory is kind of easy. You can almost achieve zero waste. On the construction side, it becomes a little bit more difficult, and it's not so well controlled. And but if you can succeed in creating kind of factory conditions on site, it becomes much easier. So I will give you here some overview also of robotic deconstruction. So first I show the production where we created actually no waste in the prefabrication, because just the quantity of concrete had been produced, which is necessary to precast these panels for floors, for walls, and for roofs. So there is no waste in the production of the concrete by this automated prefabrication process. And I myself, already as a student, and before my student time, my father had a precast concrete factory, so I already knew from the beginning how the mechanical work in the precast concrete industry is going on. And then later it was easy for me to automate it, as you can see here. We also tried out some 3D printing where you can reduce the waste more. But I'm not so much into the monolithic 3D printing, which is propagated by many people. I think it's maybe smarter just to do some kind of a component 3D printing, as you can see here on the example. So you have the benefits, and you don't print the whole building, but you just print some part, which is a sort of customization part where you can really use the potential of 3D printing. I don't see a sense in 3D printing if you have a long wall, a couple of meters. This could be also done by a conventional prefabrication process. But if you have a customized part to do, or some adjustment component, which is unique and each part is different, then you might use 3D printing. But it's just my idea. I know the mainstream talks about different things, but I think it's also a task of some university teacher to point out, to show different ways in the future, maybe. One of the interesting projects we had before the 3D printing time was we did the robotic prefabrication of a crazy design by Franco Gehry in Germany, and each panel was different. So what I did actually, I carved out the negative form, styrofoam, for the prefabrication of precast concrete panels, and each panel had a different shape. So by this way, we also had no waste, except for some of the styrofoam, which was grinded out. But it was a good, safe, and precise production and on-site assembly on time. And the other 3 sites, which used bricks and cast on-site concrete, they had lots of waste and many, many problems. And then, of course, most advanced in prefabrication is Japan, where I did my doctor, and the companies like Toyota Home or Sekisui Heim and House, they have automated prefabrication companies. And here also you see on the upper right corner, this is the only waste, which is not a real waste because it can be recycled within the factory. So, so this is the first advantage. And on the lower right side, I used this at my previous place, University of Karlsruhe. I did this robot for simulating all kinds of assemblies for not only concrete panels, but also for brick buildings and how to build them automatically with robots. Also in Japan, in order to not only assembly quickly, we assembled this house of 150 square meter, 2 floors in 4 hours, but also it can be disassembled. So within 2 weeks, you can disassemble the house, you can renovate, refurbish it, add some new kitchen electronics, better insulation and home electronics, and then bring it back or sell it as a second house. And in the meantime, the owners, they take their vacation, and once they come back, they can move back in the renovated house, or the house is being sold and they got a new house. So both ways is possible, and this modular construction is very good if you design the joints in a way that they can be disconnected. And this was here my task. I focused on joints, and I called it robot-oriented design, which is also the title of the first Cambridge University Press books. And so here you can actually achieve the kind of closed-loop manufacturing and recustomization, because the same units can be disassembled as they have been produced and brought back to the same factory and then be upgraded. So it's kind of interesting. It's like like in aircrafts, and aircraft have a quite long life cycle because you exchange many components in aircraft, and so they can fly if they're well maintained 50 years or even 100 years. So I want to show you now some kind of on-site task. The single task robots, I have been involved about 50, and we described about, together with Dr. Linner in the 5 books for Cambridge University Press, construction robotics books, we described about 300 systems, and we are now working on a 6th volume. And here I want to show you my first trial with robotics, in which I started in '85 in the Research Institute of the Ministry of Construction in Japan. And here I designed the block, which was assembled automatically. And because of the earthquake, I had to place in reinforcement. So the thing is that picking up reinforcement bars is very difficult for the robot. So I split up the reinforcement into each of the block units, and I joined each of the reinforcement. So and the advantage was I could actually disassemble it again. So this wall which I built, I could actually disassemble it again. And I think this is the clue. So we don't throw away the things, we don't smash it and crush it with the by the demolition or by implosion like in the United States, but we can actually disassemble it systematically and then renovate it or replace it totally. So also what is important and interesting is, of course, all the exoskeletons and this augmented reality can be used together here, examples from Boeing, and you can get the information. And also for the facade renovation, this is something which is important now in Europe. 98% of the building stock has to be renovated. And this is showing you one of the examples for the now integrated automated on-site factories. So trying to generate some kind of factory condition on-site. I was involved in the development of the first system. I worked for 4 years part-time for the Research Institute of Shimizu Corporation, and we developed this smart system. And here you have one of the 20 robots that simultaneously built the high-rise, and the same system can go into reverse actually to deconstruct the building from top down. And is also in wood, of course, it's much easier. We have this project here for the European Commission, where we can also improve the facade by wooden facades with a better insulation, and the old buildings which have been built after the Second World War can obtain a better facade, and also to meet the new Green Deal goals of the European Commissions. And what I'm always trying to do is to get the whole life cycle. So I included 2 companies from Spain and from France into this project. They prefabricate the facade, because this whole system, the new facade has to fit to the old building, and the old building, which has been built maybe 40, 50 years ago, is not so precise, but the new build facade is precise. So we need to adjust the high precision facade built automatically to the low precision building built 50 or some years ago. And here we first developed this. Also, the joining system again is very important, because in the joining system for the new facade or the high precision facade on the old unprecise building, I use 3D printing, because there's a small component, the joint, it can be 3D printed very quickly, and each of the joint is different because of the tolerances of the old building. And also we developed an innovative 8-cable driven parallel robot, which has never been used before on the facade. It had been used in other industry like the aircraft industry. Already before, I had some experience in Japan with inspection, maintenance, and service robots for the facade. I show you some examples here. I don't go into detail. You can check it up in the Cambridge books. I was involved a little bit in this robot. Here I designed the joint between the facade in such a way that the robot could also travel along. So the facade became a little bit more expensive as a guide rail also for the robot, but the robot became cheaper. So the whole life cycle cost became cheaper. So for the robot, it was easier to paint, inspect, repair the facade of the Shinjuku Center building in Tokyo. Also, some of the interesting robots here putting new wall tiles to an exterior wall, which is very difficult, but it's technically possible, and all kinds of not really robots, but teleoperated devices for facade assembly, interior assembly, scaffolding assembly, and so on. And here you see the problem on the right side. What happens if you assemble a facade? You need 5 people, and they sometimes, when they have to pull in the facade, they squeeze their fingers or their feet, or the facade hits with the joint, the concrete, and then later you have some leakage of rainwater. So I thought about this 8-cable driven robot, which can also move in the Z-axis to the facade, so you don't have these critical movements by one cable of the tower crane. And this idea I got when I visited the Airbus factory in Toulouse. After Tokyo, I had a job in France at the CNRS. And also I'm holding an American commercial pilot license. So I always check the aircraft technology. So I've seen this robot inspecting the A380, the biggest Airbus, which has been stopped now. But I thought this is kind of interesting. So we could use it, flip it around 90 degrees and use it for facade repair, maintenance, inspection, assembly, or disassembly. So here you see how it moves. So it can move in all directions. And if you flip it over 90 degrees, you can use it on site. Okay, I just go on. So here you see the components, how we had to adjust to the unprecise existing building. The joining system is again very crucial, like this robot-oriented design concept. And then we developed especially a modular end effector, which was compensating the different tolerances of the high precision facade to the low precision existing building. And then we could also install it, and we simulated it first. And here you see it now. It's a little bit treated like, I use the terminology of the aircraft, yaw, pitch, and roll. This is how you define the movement of the aircraft in air. So sorry for this, but I'm always referred to aircraft since it's like an airplane flying to the facade. And then we tested lots of drilling devices. And now you see the point with the 8 cables, you can even make a Z movement. under some kind of cantilevering part of the building. So here we tested in my laboratory the adjustment of the joining system, and then we tested it first in Spain, and then it was brought on site, and the whole system inside the yellow cage has been done in my laboratory. And this was the crucial part for compensating the different tolerances between the high precision facade and the low precision building. And of course, we had to redo it, the first prototype, and then finally last autumn, the second prototype worked well on a real construction site near Madrid. You can also see a video on YouTube on my homepage. Zero Plus is another project which could be interesting for the COE. Here we work together for different settlements, one in Cyprus, one in Italy, in France, and in Britain. So by prefabrication, automated prefabrication, we can bring down the cost of near zero energy buildings, because normally the requirements are very high and it becomes too expensive and unaffordable for common people. So the only way is to automate the production. So this we did here. Again, we thought about the economic automated prefabrication in order to reduce the cost and have more performance in the component at lower cost. And this can only be achieved by automation. And I show you now the further repair, which robots can be used for repair existing buildings. And we also built new kind of kinematics. Here are some examples. I was involved in Japan. And this experience we use now for the present, some welding. The only problem with welding is it's difficult to disassemble. And for the finishing of floors, and which can be also used to bring in new surfaces of floors. And for the interior is also a big thing because the life cycle of the interior is much shorter than of the primary structure. So here we developed, before I was involved in Japanese robots, and the BR2 Type 1 and 2 are developed in Munich, the first maybe German interior robots. You can see it also in my lab. And here some kind of special kinematics. Also, I was involved in Japan. This is the modular approach I developed for the robot I did in Munich. I have a basic module for traveling, and then I have different working modules which I can place on it. So it can do all different 7-8 different tasks. The work module can be exchanged for renovation, for construction, whatever you need. And this was based on my previous experience in Japan with this robot here for fireproof coating, or later you can take off the asbestos fireproof material with this robot. So, and then we had a project, sorry, I lost the data. I had one project in Mumbai, but I lost the data. I can show you one project we did recently for Cairo. Here also are many informal settlements which have to be repaired or recycled in a way to improve the living conditions of the informal settlements. About 6 million people in Cairo live in these informal settlements. And we developed this kind of system, which brings in a certain structure. So I'm sorry, I don't use machine learning and the advanced stuff Dr. Raphael is using. I'm just, because in the construction site, there's always some disturbances. So I use very straightforward systems. And then here's the example, what we proposed, and actually build a prototype for Cairo. And it can be easily, here you see the typical informal buildings, they add on top and on the sidewise, and then it sometimes becomes critical because they overload the structure. So what we propose some kind of subsystems. It's like when you go to the dentist, you have your inlay, and then we bring in some high-tech inlay for the energy production and for the recycling of the waste of this building. And they also can do some farming on the roof, and this kind of inlays or this kind of intelligent units, which can be when you replace your teeth, can reactivate the informal settlements in Cairo, for example. And so we have energy subsystem, we have a mobility subsystem, and a work subsystem. And then we split it again up in modules, and so they can be easily transported and erected by the people by do-it-yourself. Like here, for example, they can do it themselves because they don't have money to ask a construction company. And it becomes a modular system, which can be also not only built, but also replaced and disassembled again. And including the interior, which is very important. In Egypt, in Cairo, they have the mashrabea, the kind of window where the woman sits behind the window, but you cannot see it from outside, but she can see the road from inside. And here we incorporated also some photovoltaics. So the mashrabea has a dual use, decency, and also generating electricity. And here how they can build it themselves, so it becomes more structured and less chaotic. And they can add on top also all kind of energy producing systems or farms on the rooftop. And for this, you also need joining system, which can be disassembled again. For example, this buildings in Germany already had all the installations, and by joining together, inspired from the Japanese carpenters' joints, we could also join the services at the same time. And here, for example, in Germany, we don't have air conditioning, but this could be also used maybe in Chennai, including for air conditioning. This unit is just within seconds installed and generates the hot water and the heating, and normally takes 2 hours to install it. But here it's just a plug and play system, and it can be disassembled easily. And this technology we transferred to Cairo, and then also for the interior, and the same time for the aging society. So the people can retrofit their old buildings, houses, apartments, and then they get inside new high-tech furniture, also for elderly to live independently. And we somehow, it's maybe a robotic furniture because it has a lots of subsystems from robotics and sensors, actors, and then but it doesn't move around like a mobile robot. But it has on this local area, it has some robotic capabilities, so checking the health of the people, helping them to put on off their shoes or their coat, and checking the health status. And also the interesting thing is that many accidents happen nearby the apartment. 70% of the accidents of elderly happen inside the apartment or next to it. So here we take care of the mobility. So safe mobility, if they fall, we catch them so they don't hurt themselves. The bed becomes like a robot, and it can be also transformed. Maybe you know the Transformer movie, which was inspired by the Japanese Gundam or Gatai toys of the children. And this also our furniture can change into different configurations like a transformer. So the bed can become a workstation and so on. And the kitchen also, if you're in a wheelchair, you can prepare your food, or you can even work, even you are confined to a wheelchair. And all the components can be disassembled again. I think this is very important. I got this idea from Japan because they disassembled the building during the Tokugawa period, about almost 300 years. They had a peaceful period before the Western countries forced them by cannon boats to open the country. They somehow moved from the different, how you call it, principalities. They had to move to Tokyo, to the capital. And they disassembled the buildings from their hometown and brought them to Tokyo and reassembled them. And then after 2 years, they went back. So they always disassembled, reassembled, and transported. And I thought it's kind of interesting. So I used a little bit similar joint like in carpentry. and fitted it out with services. So it could be also disassembled. The same we applied here. This kind of furniture leads to also no waste, because you can disassemble it, you can upgrade it, you can lease it or rent it out to other people. And so I think this is also reducing the waste, because also the interior creates lots of waste. And here you see how we develop it, and it's for made customized for each person, because elderly have different deficiencies, and they need special new type of furniture, not to be pushed out to the care home, but they want to live in their own apartment. So we can retrofit the old apartment, and this can be also disassembled again and brought to another person who needs it, and also fall detection and so on. So the building becomes a kind of secure living system. We can check the health status, like electrocardiogram, blood pressure, blood oxygen, and so on. While you're sitting on the chair, we incorporate the sensors in the chair. So it's a little bit like a robot. The chair has all the sensors and don't need to go to the doctor to get your values, and helping you putting on and off your shoes. Maybe what is interesting is then in the center, you see a mini crusher. This is the only crusher I show you, because it's a very compact crusher. And I like this crusher, had been developed by Komatsu. And it's a very small crusher. It can go into very narrow roads and on small construction sites, like in congested areas, like in Tokyo, in the larger metropolitan area around Tokyo. You have 40 million people. So half of the German population is living in the larger Tokyo area, which is still one of the largest metropolitan areas in the world. And therefore they developed these mini construction machines. And I think this little crusher from Komatsu is kind of interesting because it recycles the material on site and uses it as foundation material for the new building. The same for the facade on the left side, or for this deconstruction of this tower. And here you see the deconstruction of a high-rise building from top down. Actually is noiseless, dustless, and 93% of the building can be recycled. Some parts are disassembled as the facade, because it has been modular, but other parts, like the primary concrete or steel structure, have to be crushed, of course, or welded, so they can disassemble the steel beams and so on. And also here I show you this. I designed a joint for disassembly as well as for the facade, and this joint was also good for robotic construction, but it could also, the facade could be disassembled without breaking any joint. I think this is very important in the future to consider. And here my doctorate thesis was applied to another Japanese automated construction site. And whatever can be assembled by robot, I designed in such a way that it can be disassembled again, or for floor panels, and again for the facade, for interior, and especially services. Services don't have such a long life cycle as the primary structure. So here I got an idea from the shipbuilding, and shipyards as well. They use these bundled tubes and then they assemble it. I thought this we can use also for building construction, because it's easier to assemble or disassemble the whole bundled services rather than one tube or pipe by itself. So here another disassemble construction site of a hotel in the center of Tokyo from top down. And okay, so what we do is actually to think about this all the technologies. I think I would just use 3D printing on certain parts, not of the whole building, customization parts, and which cannot be mass produced, and or for joints or whatsoever. And this kind of modular concept, which you can disassemble systematically, just like in aircraft maintenance, and orderly extend the life cycle, and therefore have less waste infrastructure, I cannot show you so much, but I heard there's also one professor in the COE who is taking care of infrastructure. I also have a concept here. Maybe next time I can show you. And I don't know the English word, but I used robot repair environ, is French, environ environments. Maybe this is the translation of it. I think the environment and environ is a kind nice of word. I don't know whether it exists in English something. And this is what we have to take care of in the future. Could be maybe also interesting for the COE and maybe some of the visions for the future, because also Chennai, I've never been there, but I know it's a nice, very congested area. So you have to take good care of the whole system, of the above ground and below ground, the infrastructure, and think it together. Because normally, since I studied both architecture and civil engineering, it's two different worlds that don't talk to each other. So I'm always trying to combine civil engineering and architecture, and of course, infuse it and try to improve it by automation and robotics. So our competences already have been explained a little bit by Mr. Kumar. And if you want to check more, you can check my homepage. There are several videos on it, also YouTubes and my talks in English, French, Japanese, and German. And you can check the Cambridge books. They're all written in English, so it's easy to understand for you. So, okay, so thank you very much, and looking forward to our cooperation in the COE.
Thank you, Thomas. Thank you so much. It was a really interesting talk. You covered a wide range of topics, and I'm looking forward to the questions from the viewers. So we can, you're open for questions. I think we can, let me see if I can, we have two channels. We have a YouTube channel as well as the Zoom channel. So people on Zoom can raise your hands and we can then take up the questions. As you raise your hand, I'll call out. People from the YouTube channel, Varun, you'll have to feed it into the chat. Okay. So here is a question, Thomas. I don't know whether you can see it.
Yes, yeah, okay, yeah. Robots take away the need for manpower and may create unemployment problems. Yeah, I'm not so familiar with the Indian condition, but what my experience was that I also spent some time in the 70s in US, in Texas. I worked those days for the most advanced, in my opinion, American prefabrication company. It was called Zachary. It was in San Antonio. And they were the first one to use modular concrete construction. They prefabricated already in the 70s the whole bathroom units, and they built a building for Texas A&M University in College Station, and I could see it. And then in the 80s, when I again was in the States, this time in Chicago, I visited a company, and suddenly they stopped using industrialization. I asked them what happened. And then they said, now we use cheap labor from Mexico. And so what happened is that the Americans, the Texans, didn't want to work anymore for Zachary because it was dirty, difficult, dangerous job on the construction site. And the company used cheap labor from Mexico. And so it depends, of course. In Germany too, we do it this way. After the Berlin Wall came down, we used lots of cheap labor from Eastern Europe. Before there were Turkish, Italian workers, and they, in the end, they didn't like this hard conditions. So the East Europeans came, Southeast Europeans came after the Berlin Wall came down. And also German construction somehow didn't develop any further, according to my opinion. And now we have a pretty messy construction sites in Germany, like the Berlin airport took for years. It's several times cost overrun. The Elbphilharmonie in Hamburg, 10 times cost overrun. time schedule beyond what was planned. Stuttgart 21 main stations should be finished this year. It might be finished maybe not even in 25. So there are lots of problems that happen. So either you bring in a cheap labor from abroad. I don't know the situation in India, how it is, maybe from different parts of the country, or you try to automate. And I think after my experience in Japan, I think it's more humane if you give the dirty, dangerous jobs to the machine and you train the workers better, you upskill them, and then the life becomes safer, the construction work becomes safer, they make more money. And so I think this approach is not bad, what the Japanese are doing. It's different from Western countries. And I'm somehow propagating this kind of way by automating because it also increased the quality of life. Like all the advances we have now in modern society is due to industrialization, to automation. So I think in construction we should do it too. And of course, it will not come from one day to the next day. I'm working on this field now 40 years. But I just think it's also more humane, because if you see all the occupational diseases of the construction workers, the masons in Germany, they are ruining their body in the early 50s. And so I would just propagate this way of what I showed. So I don't think it's a conflict. And when I talk to construction workers, actually they like it, and they would like that the company owners buy these robots, but they don't buy it because they're still expensive and it's cheaper to get some cheap foreign labor. So it's a kind of modern slavery maybe. So I rather think robots can avoid this kind of exploitation or slavery in the future. That's just my opinion, but of course I'm not familiar with the Indian situation. And
I can add to that, Thomas. I'll briefly add to that. In India, what we look at typically is three types of projects. We have national level projects, which are mega projects where we actually need global best practices. So, we have, for example, the high-speed rail coming up. We have freight corridors. We have large projects for infrastructure where if we don't use automation, they will not be done on time. So we use almost best practices. We have then the medium-scale urban projects, which are more mechanized than automated. And then we have other projects at a third scale, which we don't need. The amount of automation and mechanization is not important, but labor creation is important. So I would believe in these three data as India is concerned, and I'm sure many of the developing and emerging countries have the same approach. And when we talk about labor shortage, we face the same. The skilled labor shortage is there in India also. I mean, it seems to be paradoxical, but that's a problem which we also face. So I think the three-tier approach is what we are looking at, and it kind of aligns with what you're also saying.
Yeah, then maybe it would be interesting. I don't know what the COE. I'm not so. I read a little bit about your new COE, but then maybe to add some kind of upskilling or training for the construction labor would be maybe good.
Absolutely. Because right now it's not a skill sector. It is, you become a mason just by being on site long enough. So that is also something that's worked out. Just going on, I think the next question we'll take from the Zoom. I think Varun, you have your hand up.
Implementing robotics, why are not I don't know why you're not implementing robotics. It's also not implemented much in Germany.
I'll take that question, Thomas. I'll take that question. But Varun, you have your hand up. Do you want to talk about your question? Okay, Varun's not coming on.
No, Varun is copying the questions from the YouTube channel to the Zoom channel. So all the questions from the YouTube channel are also posted here.
Okay, so everything is okay. Then we'll take it in this order. Okay, then I think implementing robotics in India, I think I'll just answer that very kind of in a broader fashion. The main reason is there is capital cost, and there's always a long-term cost, and sometimes there are multiple reasons, but one reason I clearly see is that sometimes our planning systems are not feeding the work. The fronts are not available for automated construction. Investment in automation means that you need continuous work. And sometimes our planning does not enable that, which means a capital investment is almost not returned immediately. In contrast to that, a labor-based system, you can exploit the labor, is the way Thomas said. You can hire, fire, you can do many things, very flexible. That's why it's retail. There is many more facets to this answer, but I will keep it at that for now, from my perspective. If Thomas wants to add to that.
No, I agree with you. This hire and fire, I experienced, not experienced, but I could see it in United States a lot. And therefore, it's very difficult to acquire skills for the construction labor in United States, because sometimes they don't know whether they can appear again on the site the next day. So it's exactly how you said it, because you also spent time in, I think you were in Austin or where, or?
Yeah, but I see almost globally, like you said, some parts of the US and in many parts of the world, construction labor is migrant labor.
Yeah, that's a problem, I think. And we need skilled people. Like I mentioned you, I as a student, I built a little house after it burned down in a little village. Only 300 people live here. And now just last year, I remodeled the roof. I did 40 years ago, because as a student, I didn't have experience. I made many mistakes, and the insulation disappeared and everything. So I asked the carpenter of the village, and he was still there, and he knew it, how his father helped me building the roof. And there was this skill in the village is still available, but in big cities, it's not so. So it's a problem, as you mentioned, hire and fire, migration, migrant construction workers in the United States. They move from state to state, and I think it's a real problem also for the society. So I think I agree with you that we need to change the system. And also, in order to improve the whole, because living and housing is one of the major needs society needs. So each person spent most of the effort for decent housing. So why not improving this and make it more affordable and better and safer and more sustainable, like the goal of the COE, reducing the waste, make it better for the. This is actually one of the biggest spending each household has to put up with, next to nutrition and so on. So I think it's very important, the task you're dealing with in your COE.
Sure. I think we go on to the next question, which is about the pros and cons of using machine learning for robotic processes.
Mm-hmm.
Do you want to take the question? I think Benny can add to it after that.
But machine learning, I don't know much about machine learning. So
Benny,
I think Benny can answer this better. He
Yeah.
has something machine learning, so Benny can answer better about machine learning.
Okay. So my answer to that is, there are certain tasks where we have to use machine learning. For example, for assembly, if there is a lot of uncertainty, and we have Professor Bock mentioned about this fabrication tolerance. So if under such situations, if you can make use of a camera to find out where exactly the parts are situated and how we can align it. So these are some of the areas where we can use machine learning. So what people say is there are some tasks which can never be done by robots, because we need to have hand-eye coordination. We need to make very fine adjustment, and we need to adapt to the particular situation. So these are the areas where people think robots can never work. But I think this is where machine learning can make a difference. So we saw the robotics has improved so much in the last few years. For example, this Boston Dynamics robots are able to do almost impossible kind of things. And this is possible only through machine learning. So there are certain tasks for which we can use standard robotics, but there are more intelligent control where we need machine learning. So I think we'll need both. And machine learning can definitely improve the capabilities of robots.
Yeah.
Yeah, I think this is a good approach you have. And I'm just using the trick that I I tried to adjust the periphery around the robot on the construction site to the robot. So this is actually my trick then. Therefore, this robot-oriented design, or try to create this kind of predefined condition on the construction site. Because my experience, but nowadays vision systems are much better than when I started with robotics 38 years ago. So the vision system became more powerful, so Benny can use it. But my experience was that there's so much dust and dirt on the construction site that lots of these sensors fail. So I tried just to make it kind of, like a blind person. A blind person can live if nothing changed in their environment because they remember it. So I try to precondition the construction site, and then you can use the robot and very robust sensors. But I hope that Benny is succeeding, and now the vision systems are more capable than in the past. So looking forward to see Benny's results when I come to Chennai.
Good. Okay, next by Varun. He had a question on the cable system. Is it only for maneuvering, or is there drilling and installation also on your facade?
Both. We do everything. We do actually more. We do the scanning. We do the scanning of the facade, the points where we have to fix the joints for the new facade. Then we know it. Each joint has a different. The facade is not straight, so it's an old, for example, old building. Some deviations of a couple of centimeter. Then each joint where the facade is attached is different in 3 dimensions. Once we scanned it, then only the part where the joint has to be fixed, we 3D print the joint, and this is very fast because it's just a small joint. And then the robot drills and then installs the joint, and then the robot brings the facade and attaches it. So the robot does quite much actually. And also we did another robot 2 years earlier before the one with the cables. We used 4 cables, like in Hong Kong. We did it for Hong Kong. They used the gondola for the facade, grinding, painting, and so on. The social houses in Hong Kong. And they travel 4 or 5 times, the workers on the gondola. So we robotized this project for Hong Kong. But the problem was with 4 cables, the gondola was swaying. And then we had to use vacuum suction pads, so the gondola was fixed for the robotic process of grinding, of plastering, of painting the facade of the social high-rise buildings in Hong Kong. And then with the 8 cable, with the cable-driven parallel robot, it's very stable. That's amazing. It's very complicated mathematically to calculate the trolleys for the 8 cables. But if this is well controlled, then it's very stable. That's interesting. And then the robot could really drill and then assemble the facade and do all the processing, can do much more in the future.
Good. So we go on to the next question is on the safety concerns associated with robotics.
No, basically the safety is much better because there are many accidents that happens on the conventional construction side, and with robots, no accident happened. I mean, I'm following this field now since it started, since almost 40 years. And there was only one problem once with an automated construction site in Japan. There was one hydraulic hose for the push-up system that broke. But what happened is the system stopped, and they fixed the hydraulic hose, and then it went on. There was never an accident, and only within the projects I know, the last 40 years, only one incident, but no accident. So it's actually much safer because everything is well pre-planned and very structured, and the sites are very clean. It's actually safe and a nice environment.
Okay, thanks, Thomas. So we now go on to a question by Professor Balim. I think you should read it. Can you read the question?
Where?
No, okay. So this let me summarize. Basically, Professor Balim says that
Okay. Cement-based.
yes. So this is a problem we face in India too. When we try to recycle.
Yeah, I'm not good with materials, but cement-based. I was wondering in India, maybe I don't know. Indian climate is very tough because of the humidity. So
It's not just the
I have
I
seen
think-
some kind of bamboo structures or some bamboo.
No. Thomas, if I can put the question another way, how much of recycling takes place in Germany? How
Oh,
much
I've got-
is demolition recycling?
how much recycling takes place in Germany? Oh, I don't know the numbers. Sorry, I can get it later.
Sure. I think the issue we all face is that when you try to recycle, because it makes sense, there's a lot of demolition, there's a lot of waste that can be segregated and recycled, but then the quality is it's so variable that you cannot characterize it. So this
I think the problem is sometimes you don't get the real numbers. For example, since the Berlin Wall came down, former West German companies try to get rid of the waste to Eastern Europe. So sometimes the numbers, official numbers, are not the true numbers because, you know, we push the waste away to Eastern or somewhere else in the world. And so you sometimes even the official numbers are not the, so it depends. You have to verify. It's very difficult to get the right honest numbers on the recycling rate.
right. So I have just one extension, which is you showed that I think it's a Komatsu crusher, which
Yeah.
came on site and it could do the crushing. Does it do segregation, or do you think equipment like that can be more automated to, what do you say, standardize the characteristics of material?
Yeah, I think so. Therefore, I showed the picture because I like the small compact size of this Komatsu crusher. And of course, it can be more automated. I think it's also not so expensive. I think the small machines can be afforded by small companies. And since you mentioned the investment is not done and they rather use cheap labor, I think if you have small, compact, cheap construction machines like the little Komatsu crusher, I think they can become more affordable and more automated in the future. Therefore, I showed it, this picture. Yeah, I agree with you that there's a big potential probably.
Jonas, if you want anything, if you have not answered your question directly, if there's anything else you want to add.
Yeah, no, I'm fine. Thank you very much. Thank you for that. Thank you. It is a bigger issue and we can pick it up later. Don't worry. Thank you.
No, it's an issue which we face, and I think our materials team will work on it, and look forward to your visit here so that we can discuss more about it.
Indeed. Thank you.
Of course, he wrote also the resistant because the unreliable quality of the materials. Yeah, what they are doing with recycling materials, they downgrade it for lesser, let's say, some foundation of some roads or dams or whatsoever. So they downgrade the.
But it would be nice to use it on the same project. You know, if we could actually reduce the transport cost, like Jonas has pointed out, and we could actually,
yeah.
You know, that's a challenge I think we are all working towards.
Maybe we can upgrade the material instead of downgrade by maybe adding some kind of carbon fibers. I'm not sure, but I'm not a material person.
Right. We have a question on quality control. How is quality managed in robotic construction?
Quality control is always automatically there because you cannot program a robot to do something if the quality is not right. So it's right at the first time the robot does it, because otherwise it cannot do it. So there is actually the quality control is in the system because Otherwise, the robot could not execute it. This is just like in automation in the industry. Otherwise, it can never work. So the nice thing is about the robotic sites I experienced, and there's still the last site I visited in 2 years ago in Osaka and Yokohama. They have this. They don't have any rework. I mean, it's done. It's perfect quality. Like on a conventional construction site, you have to do lots of rework, and it costs lots of money. So you get into this claim management vicious cycle, and the costs explode. So anyhow, the quality control is inherent.
Right. I mean, your process has to be standardized. So once your process is standardized, the quality will. I mean, otherwise you will not be able to roboticize it.
Yeah, you cannot program it if it doesn't work. Yeah.
A question from my colleague Shiva. Basically, how to develop affordable, cost-effective robots for developing economies. So I think the question is, a lot of times technology transfer, for example, a country like India waits for or adapts technology from Germany. I mean, what do you think is the scope for us? And so because of that, the cost in India is much higher.
I think you shouldn't use technology actually from Germany, because it's a different, first of all, the environment is very different in India. And I think you have to develop your own systems, and therefore I would propagate robust design and how to say, I build my robots also myself. I use lots of linear drives. Most of the things I did for any kind of the prefabrication robot I did at the previous university, or the interior robot in Munich, or the robot for Hong Kong, or even this one now for Madrid I showed you with the cables. I use linear drives. I mean, it's very simple, and they're not expensive. Sometimes the German technology is a kind of technological overkill. So I would rather do something robust and something which is available on the Indian market. If something breaks down, and you have to get some spare parts from Germany, it's difficult. So it's better you do the local design, development, and sourcing of the robotic components, and maybe we can find something once I can check what is available on the Indian market when I come to Chennai. Maybe we can do some local. I think it's better to do some local sourcing for the long-term development, to have a sustainable robotic development, automation, and so on. I think you should do the local sourcing. Actually, this I would recommend.
Right. So this is also got to do with the economy in terms of I mean, today, I think as we are going forward from here, we can see more mechanization in Indian construction, because so even if you go back a few, 7-8 years ago, a contractor would prefer to put what we call a builder's hoist rather than a tower crane on site. But today, a tower crane has almost become a default piece of equipment, because there is availability of tower cranes. It's again a circular question. Once people start using tower crane and find its benefits, there's more demand. So, more people actually, and then the Indian fabricators are starting to make tower cranes.
Yeah, maybe you can also work together, because Tatra also advanced company, and maybe can use some of these technologies, because they also build cars. And I found out one of my teachers was Jean Prouvé in France, and he already 100 years ago used technology from Citroën, from the French car manufacturer.
So what's happening is that the demand for these technologies grow, the local market starts meeting that. If the demand is very little, then it comes only from outside. So I think this is also driven by the demand in the local economy. And I think in answer to Shiva's question, you'll see that there's more developments in India. And a lot of times we find that developments in India are also applicable in other emerging nations. So, for example, the Indian we have our railway systems, which are now almost, lead. I mean, they are apt for our kind of usage, which also happens to support a lot of African countries as well as Southeast Asian countries.
Mhm.
You know, so there is a room for Indian science and engineering to play that role. In
Yeah.
some ways, I think the old term we used to use is a bit of jugaad, which is kind of a make-do. But I think we've gone beyond that to actually bring in science and engineering in a more systematic way.
And maybe also what I experienced in Japan, besides these robotics, was that the small they have many small, about 650,000 small construction companies, much more, 10 times more than Germany, even though the population is just half more than Germany. And these small construction sites don't have much money, sometimes only 5 people. But what they are doing, if they build a road, they start the road construction all over the place. So each small company builds some strip of the road, even so it's maybe several hundred kilometers long. The problem is when you drive along, there's some part is wide and some part is still narrow of the old road. But since they start all over the place alongside the whole road project, then it's immediately finished by small companies and small machines. So maybe this is a different approach from what I've seen in the United States and Europe or Germany, where we have this big road construction machinery and we build the line continuously, which is good for automation, but you need big investment. But for small investment, I think the Japanese model is interesting because they do a little strip in each prefecture or county, and then later they close it, you know, they start all over, let's say 500 kilometers, and each county has a little company and they build a little part of it with small companies and they know the quality, what they have to meet. And then, of course, once you're driving along, you're always driving on and off a nice road and an old road. But then suddenly it's finished because the small investments, small companies, each county, and maybe this model also of different road construction management could be interesting for I don't know which part of India and also other where they don't have so much investment because the companies are very small. So the one I showed you now from Japan, this is the most advanced, but also you can use it in combination with a different kind of approach, managing construction by starting all over the place with small companies and small machinery at the same time, and not just using the big machines, but many small machines simultaneously all over the place. Maybe this is also another approach which could be interesting.
Kind of a form approach. Okay, now just one more concept I want to introduce to the question Shiva asked. We have this concept called frugal engineering. I don't know whether you've come across it. I don't know the others who are on the. So basically, when we look at engineering for the emerging countries or developing countries, there is a concept that's emerging called frugal engineering. And as we get with more advanced manufacturing processes and design aids, you're able to actually design actually for the need specifically. So this is something which, the listeners, the audience would like to look at. But this is something that's becoming more important with the context of developing countries. Okay, that is the last question which we had on the chat box. If there are any other questions the audience would like to post or voice out, we have a few more minutes. Okay, otherwise, I guess we've had a very, very good talk by Professor Thomas Bock. Thank you so much, Thomas. I think it's been really, really, I mean, to be able to see to share with us all the experiences you've had working in this area. And we look forward to your visit here and to be able to, do some joint research and take this forward, not only in the global context, but also in the context which we are facing in India.
Okay, good. Okay, thank you for inviting me and looking forward next year to come to Chennai.
Absolutely.
Thank you.
Thank you, everyone. We'll close the session. Thanks for your participation and the questions, and we look forward to